Hello viewers. Today's topic is actually a continuation of what we have done earlier. So I've written this is part of Mathematics 101-102B, Differential Calculus and Successive Differentiation. I've written part 2 because there has been one lecture given already. So I've written revision and problems. The focus will mainly be on problems. And what I've done is here I've made a mention of the various functions for which we've already derived the nth derivative. That means we have already found for these functions, these y's, we've found expressions for y sub n. We've done that in the earlier lecture. So now we will take some problems. We have stated Leibniz rule once, but I intend stating this in more details today and touching about the Leibniz theorem a little more in detail. And of course, then getting across to some problems of finding the nth derivative of products, which exactly is the focus of Leibniz rule that we will see a little later. So I am rubbing out this part and we get across straight to doing a few problems. I am even rubbing out this part. So let's start with the problem that can be written down like this. If y is equal to say 8 times cos x to the power of 4, cos x to the power of 4, then what is the expression for y sub n? If y is cos x raised to the power of 4 and there is a multiplying factor 8 which has been inserted purposely, because the moment I start doing the problem, you will see the need for this kind of a 8 or 4. We will see that as we go across. Now what we will need here is that, this is the revision part. We write that we know when y is equal to cos ax plus b or sine of ax plus b, then the expression for y sub n is very simple, is cos ax plus b plus n pi by 2, or same argument, and for sine it should be sine. This we have done in the very first lecture that we did on successive differentiation. So in this particular problem we will need this. So these are also very, very simple to remember. The nth derivative is the same argument, cos ax plus b, but increased by n pi by 2. Similarly for sine it is the same expression inside. That's it. So we'll have to see how we can relate this function to the cosine of functions like cos 2x or cos 4x, whatever is necessary, we will see that. We'll have to depend on trigonometrical identities. So first of all, let me break down the 8 times cos to the power of 4x into simpler cosine functions. Now, we know cos 4x is nothing but cos square x whole square, that is 1/4 of 4 cos square x, sorry, cos square x whole square is 4 times cos square is 1 plus cos 2x over 2 whole square. Cos 4x to the power of 4 is cos square squared. Now cos square is 1 plus cos 2x over 2, that is cos square x whole square. So this 4 is not necessary. That's there. So this is actually equal to 1 by 4 times 1 plus 2 cos 2x plus cos square 2x. Hopefully there is nothing erroneous. So you see there was a 4 I put just to actually annihilate the effect of this, but this is not necessary. Cos square by itself is half of 1 plus cos 2x, that squared. This comes as 1 by 4, and 1 plus cos 2x whole square is 1 plus 2 cos 2x plus cos square 2x. Now we carry on by writing this as being equal to a quarter of, let's see, 1 plus 2 cos 2x. Cos squared 2x is plus half of 1 plus cos 4x. Cos squared 2x itself is half of 1 plus cos double of 2x, so 1 plus cos 4x. Hence, if this is cos to the power of 4, we will write this implies 8 times cos to the power of 4x will be, we multiply this entire thing by 8, so that will be 2 times this term plus 1 plus cos 2x divided by, sorry, this is cos 4x, not 2x, this is cos 4x. Now, once we multiply this by 2, what we get is 2 into 1, 2 plus 2 2s are 4, 4 cos 2x plus these 2 and these 2 will vanish, so we will get plus 1 plus cos of 4x. So we see the presence of this 8 actually gives no fractions in the denominator, and that is a desirable thing. So the problem, this 8 has very purposely been invoked. Normally you might get this thing, if y is equal to just cos to the power of 4x, then you will have to carry out without the 8, and of course it is not very difficult. So we write down the result, this one, and rub out the middle part, then get the nth derivative. So my friend here is actually equal to 2 plus 4 cos 2x plus simply cos 4x. And this implies, if y is equal to this much, this implies that y sub n is equal to 0 plus 4 times cos 2x plus n pi by 2. This is what we discussed 2 minutes back, plus cos 4x plus n pi by 2. So if we are talking of y2, it is y sub 2 is 0 plus 4 cos 2x plus 2 pi by 2. So cos of pi plus 2x. Cos of pi plus 2x is minus cos 2x. And here if we take n as 2, this is again cos of pi plus 4x, and cos of pi plus 4x we have done in associated angles in class 11-12. Cos pi plus theta is minus cos theta. So these can be simplified. I mean, that is for n is equal to 2, but if n is unspecified, we must keep it like this. So that is the first problem done, and I am sure I have been able to explain this simply. Next problem is a similar looking problem. I am just giving you the tricks, you know. In trigonometric functions, it is very important that the viewers and listeners and students in particular, they must be very familiar, conversant, and they must remember the trigonometric identities, at least those of them which are necessary and which they have learnt in class 11-12. Excuse me. Next problem is something like this. If our friend y is written as 4 cos x, cos 2x, cos 3x, find y sub n. This find does not look like find, so we write it properly. Find y sub n. Again, it is not a difficult one. The only thing is how to make this sort of complex looking function into, transform it to simpler trigonometric simple cosine functions, linearly connected, that means added and subtracted to each other. So what we do for that is, we observe that this is actually 4 times, if we write this cos 2x here, 4 times cos 2x into cos x cos 3x. In fact, we cut this down to 2 and put a 2 inside here. Now, this has been reduced to, the inner bracket term is 2 cos alpha cos beta, and we know that cos alpha cos beta into 2 is nothing but cos alpha plus beta plus cos alpha minus beta. I'll state the identity somewhere here. It's an important identity. 2 cos alpha cos beta is equal to cos sum of the angles plus cos diff of the angles. One might question here, why not cos beta minus alpha? The answer is very simple. Cos of alpha minus beta and cos of beta minus alpha is the same, because cos of minus x is the same as cos of x. So we use that identity here and write that our friend here, we put the 2 inside, rub this 4 out. So this is equal to 2 times cos 2x stays outside the bracket. So this is cos sum of angles plus cos diff of angles. Cos sum of angles is 3x plus x plus the cosine of diff of angles is 3x minus x, bracket. Now this is 2 cos 2x, this is cos 4x, plus 2 cos squared 2x. This is cos 2x. So we have a 2 cos 2x. So 2 cos squared 2x. That's fine. This can be simplified as same philosophy. This will be this part only, the first part, cos of 6x, sum of the angles, plus cos of 2x, that is the diff of the angles. 4x minus 2x is 2x and 4x plus 2x is 6x. Plus the friend here, 2 cos square theta is 1 plus cos 2 theta. So this can be replaced by 1 plus cos twice of this angle, which is cos 4x. Now this problem is done because we have everything reduced to simple cosines added or subtracted to each other. They are all here added. So if that is y, obviously from there we can conclude that y sub n, so this implies y sub n is equal to, well, cos 6x plus n pi by 2 plus, I am not writing all these because it's very simple, 2x plus n pi plus and 4x plus n pi by 2. So that's not being written down, but the flavor is break down the basic trigonometric function into simpler looking sines, simple sines and cosines, linearly related. That means added or subtracted to each other with, of course, subject to the presence of coefficients. Now we will see how to apply Leibniz theorem, and this is one theorem we have discussed earlier, but I will put it up on the board once again and make few remarks. So what we are trying to do is we are going to take a relook into Leibniz theorem. We can write this. I keep on mentioning that when the Germans write, they don't use a T, but all others spell Leibniz like this, Leibniz. That is how the whole world spells Leibniz, but the Germans spell it like this, and this, of course, is the correct way. Now, what is the focus of the theorem? The focus of the theorem is, given two functions ux and vx, the focus of Leibniz theorem is to find the nth derivative of their product. So, if we know, so we write focus is on obtaining the nth derivative of the product of two functions designated by u and v. In other words, we try to answer this question, what is uv sub n? That means the nth derivative of the product of two given functions designated as u and v. So we will write down the theorem, make a few remarks, and then proceed with some problems so that the concept is driven home and it is well understood.